Today I'm going to take you through the process of finishing up the collocation and 80/20 analyses to get you started on the story map that you'll have all week to complete next week. So here we go. To get started, you should open a map and you should bring in vehicle and pedestrian stops for 2023, the incidents part 1 and part 2, and I think in our group area that's called something like Philadelphia Crime 2023. When you bring it in here, it reverts back to its original name, which is incidents part 1 and 2. You'll also want to bring in the black population by PSA layer that you'll use for the collocation analysis, and that's just a layer showing the police service areas in the city of Philadelphia. And finally, you'll bring in this layer, the tessellation polygons clip. That's the fishnet I created that has the 1200 by 1200 foot squares across the city. In addition to these layers, I also brought in a series of what I call reference layers as well, and I put them into this group here. I've got the Philadelphia city limits, Temple and Drexel universities, as well as the Philadelphia rail lines that I brought in from Philadelphia's API. And in this rail line layer, it's a grouped layer, and I'm only visualizing the Market Frankfurt and Broad Street lines here. The reason I bring these reference layers into my map is just for contextual purposes, so I can kind of figure out where things are happening in the city. I know where Temple, Drexel, and the Market Frankfurt and Broad Street lines we can kind of reside in the city. So by putting them there, it just gives me a visual reference point. But you don't have to do that. I do recommend bringing in the city limits if you'd like, just to bound your analysis. So I'm going to close this out or collapse it, and the one thing you'll need to do to prepare the incidents is to make sure that you're working just with violent crimes. So to do that, you're going to go in and create a definition query, which I've already done here. But the way to do this is to come into definition query, click new definition query, and go all the way down to violent crime. And you can say violent crime is equal to 1. You'll click apply and then OK. And then just go into the attribute table to make sure it worked. You should see 1,575 violent crimes here. And over here, violent crime, that should all be a 1 all the way down that column. So now that we have prepared our data, let's start conducting the analyses. To do that, the first thing we're going to do is conduct the collocation analysis, and we're going to examine the extent to which pedestrian stops co-locate significantly with vehicle stops in Philadelphia within 8 hours of each other. And I'll explain more as we're going through the process. So go into Tools, and then over here, you're going to want to type in collocation. Click on collocation analysis. Now, for our purposes, we're using a single data set. And the data set we're using is Vehicle and Ped Stops 2023. Our field of interest is going to be stop type. We're also going to include a time field of interest, and there's only one date stamped field in this data layer, so it's the date time of occurrence. Now, the category of interest is going to be vehicle stops. And we're using vehicle stops because they occur much more frequently than pedestrian stops do. So that's going to be, it's kind of like our reference category. So the neighboring category will be pedestrian stops. For a distance band, we know from class that police departments often think in terms of 500-foot intervals. So for our distance band, we're going to use 500 feet as our marker here, and we're going to come down and use US survey feet. We'll keep the temporal relationship as before, and we want to include a time step interval here. So remember what we're measuring. We're trying to measure or get a sense of police enforcement activity in concentrated places over concentrated time periods. And then we're going to overlay that result with the violent crime 80/20 analysis we conduct. We want to know if pedestrian stops cluster with vehicle stops during specific 8-hour periods, because to the extent that they do, that might indicate some crackdown activity or specialized, focused enforcement in various locations. So we're going to go ahead and put 8 for the time step interval and specify hours as the unit of measurement. For the output features, you want to just make sure that you create a title that works for you. Collocation analysis, it's going to suggest one. Maybe just put an underscore and do something like 500 feet underscore 8 hours. And then click run down here. And once you do that, you'll come up with this. And here's the results of that analysis. You'll see it's kind of all over the place. And your job here is to try to limit the chaos that occurs in the map. So what I would do if I were you is look at only the collocated and significant vehicle and pedestrian stops. The way you can do this is to put a definition query on this under properties. Go back to definition query, and then it's the LCLQ type is equal to collocated significant. Okay, and that's what you're going to come up with. So all those brown points on the map are collocated, are stops that are they're vehicle stops that are collocated with pedestrian stops within 500 feet and within an 8-hour time period. So these are places the police focused some enforcement activities throughout 2023. So your collocation analysis is finished. Once you get this point, you're done. And you can actually turn this off if you want, like I'm going to do here, and come down and start conducting the 80-20 analysis. The 80-20 analysis is going to show us how much of the city certain clusters of violent crime take up, so to speak. So to do that, we're going to go back to Tools, and we're going to run 80-20. Click on 80-20 analysis. We're going to run 3 of these 80-20 analyses, if you remember. In fact, let me open this up over here to give you a sense of what's going to go on. The first one you're going to run is a violent crime 80-20 analysis using the cluster method and a 1,200-foot tolerance. Next, you're going to run a violent crime 80-20 analysis using the closest feature, and you're going to specify the PSA layer as that closest feature polygon. And then the last one will be an 80-20 analysis using the closest feature, but using the tessellations as the polygon. And we just want to see how these 80-20 analyses, how the different methods might change or support one another throughout the analysis. So the first one is going to be the 80-20 analysis using the cluster method. So the input is always the same. It's always going to be the incidents, part 1 and part 2. And it should tell you that you're working with a filtered data layer here, and it'll show you 1,575 points. So that if it shows you that, that's good. The aggregation method is cluster, and we're going to specify 1,200 feet. And you can use survey feet here. We're not going to mess with the output fields. Make sure that you name this thing something that you can remember. So you might want to say underscore cluster underscore 1,200 feet. Just so when you run it and you come over here, you can figure out what it is. So after you run it, you'll come up with this layer. And you're going to want to change the symbology so that we can better see the different points on the map. There's more going on here than this analysis suggests, but it's because those points, the smaller points, are so transparent that it doesn't look like there's a whole lot going on. And then you're going to overlay your collocation layer on top of this. And you'll do the same thing now for the PSA. So you're going to come back over here and just rerun this 80-20 analysis, only this time you're going to change the method, the aggregation method, to closest feature. And the input comparison feature is going to be the PSAs. The tool will aggregate the crime points, the violent crime points, into the PSAs and then calculate crime densities for you within PSAs to give us a sense of how strongly violent crime is clustering within certain PSAs. So you want to make sure to change the name of the output feature class to something like CF for clustered features _ maybe PSA, and then click on run. The new analysis will come up, and this is what it'll look like. So you get a sense over here of how well the PSAs are harboring clustered, violent crimes here. It's interesting that this occurs right along Broad Street here too. So this is your second 80-20 analysis. Again, you'll overlay the layer from the collocation analysis to see just how much police enforcement activities were concentrated in these PSAs. PSA, again, means police service areas. And these are areas where police officers are assigned to work within beats. So it's kind of like the neighborhoods for police officers, at least for patrol officers. All right, the final analysis you're going to conduct is a third 80-20 analysis. And pretty much the parameters will be the same. It's still a closest features, but instead of using the PSAs, you're going to use this tessellation polygon clip. Now for this, you're going to change the output feature class name, get rid of the PSA and call it something like TESS. You just want to remember that these are 1,200 foot by 1,200 foot squares or grids that are going to be stretched out across the city. Click run here, and once it runs, you'll be greeted with this output. So the advantage of using tessellations over the PSAs is that the tessellations are all the same size, so that the crime densities can be calculated using the same geography. You're going to want to open the attribute tables for the 80-20 analyses. And as you look at these attribute tables, they should already be sorted by cumulative percentages. For example, this cumulative incident percentage, you're going to want to scroll down to the first time you get an 80, because that means 80%. Everything it's remember, the cumulative percentage equals the row and all the rows above it. So we reach 80 right here. So we can say that 80%, this is the tessellation table, we can say that 80% of all violent crimes are concentrated in roughly 18% of all these grids. That's a pretty strong indicator of the 80-20 rule right there. We're only a couple percentage points off, and it's very close. You want to do the same thing for the PSA table, and also just for the 1,200 foot clustered table. You want to scroll back down, and I'll run this through you here really fast. Open up the attribute table here. This is the one that's the clustered with 1,200 feet. The cumulative percentage here, if we scroll down, the first time we get to 80, so we can say that 80% of all violent crimes are clustered in 20% of the locations of Philadelphia using that 1,200 foot distance band. So this is good evidence for the 80-20 rule. So now when you write up your story map, and I'll make sure to give you some better instructions in our Blackboard site, but when you write up your story map, you're going to want to talk about the 80-20 rule and how well the violent crime in Philadelphia adhered to the 80-20 rule based on these three analyses you conducted. And then on top of that, you'll layer the collocation findings to determine the extent to which police enforcement efforts were concentrated in these highest violence areas. Okay, I hope that's it. I hope I've helped explain this pretty well. And I look forward to your story maps. So I'll see you. Thanks.